Okay, now let's look at this question, okay? They said let f be the function defined by fx equals cosine square x. Approximate definite integral 1 to 3 fx dx integration using the middle point Riemann sum with intervals of 1 to 1.6, 1.6 to 2, and 2.2 to 3, okay? So when you do this one, what you need to do first is what? So you need to do is you need to work on the Riemann sum, right? So before you do Riemann sum, you can do some general sketch, okay? So when you general sketch, you go like this here. This is the x, this is the y, huh? And then suppose this is the 1, and this is what? 3, okay? General sketch. And then the function, even though we do not know what's the shape of function, we just randomly draw it, okay? So from what we know, this function will be decreasing and open up. Later on, we will know that. I will show you, okay? But right now, just anyone will just sketch on that. And then you will see this is the one here, Riemann sum, huh? So first, you cut into this intervals first, okay? So 1.6, for example, this is about 1.6 here. And then this is about like a 2, okay? This just randomly, just for the illustrated purpose, like this. Now, what we need to do is what? We need to find out the area underneath of the curve, but we do the estimation. Be careful here, they ask for the middle point Riemann sum, okay? So how do you do the middle point of Riemann sum? We go like this. We make this one here, this middle point. 1 to 1.6, the middle point here is 1.3. In between 1.6 to 1. For 2, this middle point will be the 1.8, and in between here will be 2.5, okay? So you will make the rectangle like this. So this integration will be estimated as this. Find the area underneath of this rectangle, and then this point here, find the area of this rectangle, and then find the area of this blue rectangle, okay? So how do you do that? You go like this. The base, here the base is what? 1.6 minus 1, which is 0.6, we know that. And then times the height should be f of 1.6, because 1x equals 1.6, the function value is here. This one representing what? The height, okay? Similarly, here represents the height. So that means what? 2 minus 1.6. So this one will be the base. And then we times the height. Height is what? F 1.8. And then add by 3 minus 2. That's 1. That's this base now here. And times this height, okay? This height is F 2.5. But we know the fx equals this one, so this one you can put it as what? Cosine square root 1.6, substitute in, okay? And this one will be cosine and the square root 1.8. And then this one will be cosine 2.5 or square root 2.5, okay? But so you can do this calculation, you will find out the answer. But just be careful, when you really do the calculation, you need to do is what? Change the mode of the angle in radian, okay? In radian, so you will calculate it out, you get what? 0.331. This is the answer, all right? Now let's go to the B now here. Why you do the B here? That's like this. So they told you that it is known that the f derivative is this, and second derivative is this, and would the trapezoid sum with what approximation of this one overestimated or underestimated the value of this integration. They said trapezoid sum means you gotta, instead of using what the rectangular middle point Riemann sum, we gotta use what with the trapezoid, right? So if we use the trapezoid, I'm going to erase a little bit here, okay? So we can see, right? We can see here. Now I just erase a little bit of this one, erase this one, okay? Now, after you change to this, like this, right? I still got this graph, okay? But I just need to get rid of this box first, okay? Yeah, just got rid of the box. Now, instead of using what the middle point Riemann sum, we gotta use what trapezoid. Trapezoid is like this because this graph is open. First thing first, we know that. I just try to make it like this, okay? Because we know this one 1x in between 1 and 2, this one should be less than 0, decreasing. And this one will be what? Greater than 0, means the graph will open up, okay? But right now, less than 0 is not useful for this question though. So if you do the drawing, you will get what? Trapezoid methods, right? Means from here, let's change the color here. So you only have from here to here, this trapezoid, and then find the area of this trapezoid. Yeah, this trapezoid, the other trapezoid like this, right? And the third one is like this. Because this graph is open up, so the trapezoid area always bigger than sum add together will be bigger than the area underneath of the curve. So that's why we know the answer must be what? Overestimate. Means you go through the trapezoid methods by this setting, you will get the area bigger than the actual area with the result of the integration of this. Okay, that's overestimated. But if you really want to find it, right, what is the trapezoid method, get the area, you can go like this. Area equals what? Equals to the base from here to here. This is height. This is considered the height. So you remember the trapezoid formula is what? Area equals what? 1/2 base 1 plus base 2 times the height, right? So the height here is 1.6 minus 1, and then times by the base 1, base 2. Base 1 is f1, and the plus f what? 1.6, and then divided by 2. This is the area for this part. And then you have the other one is what? 2 minus 1.6. And this one you will be what? F1 1.6 plus plus f the 2, right? F2. That will be this one and this one, the two bases, and then divided by 2, and then times what? The height. And then you can find the third part, that's this part now. That will be 3 minus 2, that's the base, that's the height here. And then half, and then f2 plus f3. Okay, if you plug into this function, you will get the estimations about like a 0.342 or 0.341. Either one is acceptable answer. All right, so that's what's this question about. Okay, so if you have any questions, for this one here, you can see that overall procedures is very clear. Just use the Riemann sum, you have a middle point, or the trapezoid methods. Okay, If you have any questions, please let me know. Thank you. Bye bye.